and thank you for joining us today on our fourth RE Tech Talk. I'm Lakshmi Bohra, your host, and I welcome you all to today's RE Tech Talk, where we will talk about hybrid technology, solar and wind. In order to integrate renewable energy sources into buildings, the IIEC and Swiss Agency for Development and Cooperation are working together on the BEEP RE project, which has led to the organization of this webinar. And we have partnered with U Solar Energy Solution for the talk series. In this series, we have been exploring a variety of topics of related subjects related to the implementation of renewable energy projects in building with our expert speakers. The series began on 17th of February. However, if you were not able to attend, you can find the link of the recordings on your registered email. Please mark your calendar for these webinars. We will also be sending out reminders and updates to all registered attendees. A quick recap on the last RE Tech Talk, where we looked into building integrated photovoltaic and technical specification for the same. In today's talk, our expert will talk about the hybrid system of solar and wind systems, and the talk will cover the background and the technical specification regarding installations and sizing of various elements. Our goal is to give you essential knowledge and information about RE technologies and their application through our highly qualified speakers who are excited about imparting it to you. Before I invite our speakers, I would like to run you through the GoToWebinar interface we are using for this webinar for our new participants. For the entire duration of the webinars, your microphones will be on mute and webcams will be turned off by default to avoid any accidental background disturbances. During the webinar, if you have any question or comment, please share the same using the questions or chat options available in the panel at the right side of your screen. The questions will be taken twice after each session. You can also access the additional informative material in the handout section. Please note that this webinar is being recorded and the recordings will be made available in the public domain. Thank you for your patience. Without holding you up any further, I will invite our first speaker, Ms. Sonia Shukla, Senior Project Manager, International Institute for Energy Conservation, IIEC, for sharing the opening remarks and setting the context for today's talk. Ms. Sonia has more than 12 years of expertise, and she has worked in the fields of clean air, electric cars, renewable energy, and energy efficiency. She is in charge of the IIEC team that work on renewable and sustainable energy projects. Sonia, the mic is yours.
Hello.
Hi, Sonia, we can hear you.
Perfect. Good afternoon, everyone. Thank you so much for taking out time for coming and joining and listening to us. Before we begin, let me just introduce the organization to you. IIEC is a non-governmental, not-for-profit entity. We were established to foster the implementation of renewable energy and energy efficiency projects in developing countries. We in India are registered as a Section 25 company. We work across various sectors, but with the common agenda of sustainable development and resource conservation. And in this regard, we have worked with multiple governments, private organizations, donors, multilaterals, and public sector, private sector. So for today's discussion, I would just like to describe the project that Lakshmi just mentioned that we are doing with Swiss Agency for Development and Cooperation. This project is known as BEEP RE, and this project aims to develop a solutions for holistic integration of renewable energy technology in the building sector. So we've been hearing and seeing integration of solar rooftop solutions in buildings from past couple of years. And this program wanted to move a step beyond and look and explore other technologies which are suitable for integration in the buildings, as well as bring down the overall footprint of the building. This program is almost 4 years old now, and we have been able to achieve substantial outcomes. Fortunately, we have also established several collaborations and engagements with the public sector, private sector, financial organizations to demonstrate the technology interventions that we have shortlisted under the project. We have also developed tools and manuals to assess the RE potential, as well as the fact sheets for describing these technologies. As Lakshmi just mentioned, these are available for your use in the handout sections for today's webinar. Besides this, we are also developing self-learning modules, as well as we are collaborating with the academic institutions, architectural institutions, which will help us in integrating the entire process and renewable energy understanding at the very basic level, so that the next generation of architects and entrepreneurs are very well versed in the technology understanding and how to create this process of RE integration. So this is the overall objective of the project that we are working on. And in today's sessions, we wanted to delve deeper into this solution which we create through developing a hybrid solar and wind project. This, as Mr. Siddharth from Revayu will explain this better, this kind of option creates synergy and better I would say generation profile for the overall electricity generation, as well as it's a more optimum utilization of resources available on site. So with this background, I give this back to Lakshmi and ask her to take it over. We'll be happy to address any questions that you would have about the project or the technology, and we'll come back to that at the end of the webinar. Thank you so much.
Thank you, Sonia, for your insightful comments. Now we will move on to our today's expert speaker, Mr. Siddharth Arora from Revayu Energy Pvt Limited. He is the promoter director to present today's talk. Mr. Siddharth has done his master's in business strategy from Thames Valley University, London. He has over 10 years of experience in startups in diverse verticals. Before venturing into the field of clean energy, he had successfully ventured into indoor air quality vertical, which is growing and doing exceptionally well. We will present your presentation through our screen, and you can just ask us to say next, and we will change the screen for you, Siddharth.
Sure. First of all, I would like to congratulate IIEC for whatever you are doing. You are doing a very good job, because there's a lot of information and knowledge and awareness that is required at multiple levels for an informed decision making to happen. And as very rightly Sonia ji said, that from last 3-4 years solar has been adopted, and rest of the alternate technologies available that can be adopted along with solar, there is a lot of gap which we together need to fill up, so that we can complement solar as a technology. I would say that why solar has been adopted, first because technologically it has evolved a lot, and now people are aware about it and about its merits and demerits. And overall in the industry there is a skill set available, and there are multiple people engaged in this solar industry now. It's not a puzzle that needs to be solved, so but rest of the technologies which can be integrated together, which can complement it, needs a bit of effort. So you guys are doing a great job, and congratulations for that. And I would like to thank you all, IIEC, everyone at IIEC, Swiss Agency for Development and Cooperation, and especially you Solar. I'm sure you Solar is doing a great job, and I got a chance to go through the presentation of you Solar. They are doing a really good job. So I would like to congratulate them as well, because they have done a good job for building integrated PV solutions. So let me start with today's session. We can come to the next slide, Sonia, now. This will be about solar and wind hybrid, how we can combine both the technologies together to optimize the value as well as the power, renewable energy power requirements for our clients and the users. So we Revayu Energy are a technology-driven, service-oriented hybrid renewable energy company. Hybrid. I'll come to the meaning of hybrid. There are two meanings of hybrid that are prevalent in the industry. So let's come to the next slide. There are two videos that can be played. This is the one on the left. If you can see, this was the very first project executed by Revayu in 2018. 2017 was the inception year of Revayu. In 2018, in Paradeep, Andhra Pradesh, this was done in a very remote location where solar was already there. Integrating solar with wind also means if somebody has already installed solar capacity and they want to have a reliable energy throughout the year, then they add a capacity of wind to their existing setup of solar. So that's what we did here, and this was for telecom tower, and the surplus power, when both were producing surplus, it to village people who were staying there. And this is the one on the right is basically a project for IOCL. We did again coincidentally at Andhra Pradesh because even though it was done from head office of pipeline division. So we are again providing them with solar and wind integrated hybrid solutions at their site. And we are now discussing with them for having retail outlets and these pipeline divisions where we can have net zero facilities where there is no need to use the grid power. Next page, next please. If you can play the video, you can play, or next. You can play it once without the audio or something. So this is our core leadership team. Prateek Gupta. It's playing. And this one was done for Pfizer. In a single phase, we did solar and wind both. This, as I told, is done for IOCL. Next page, please. Yeah. So this is our core leadership team. Prateek is the founder who founded the company in 2017 and alone. And then in 2018, I joined him and as a director as well as a pre-seed level angel investor. And the third is our director, another director who is based out of Goa. And the fourth is Mr. Sameer Singla, who is basically the now the investor who has invested in the company, and he's based out of US, and he invests into through his company's venture fund. He invests into sustainable startups. Yeah, good. So Revayu is a clean tech company with a vision of providing affordable and reliable clean power to all. Reliable is a very important word over here, because alone wind, alone solar could be, intermittent in nature, and might not be a reliable source of power, where especially there are grid issues. So wind and solar hybrid renewable energy solutions for decentralized net zero establishments. So nowadays, because many of the companies wants to go net zero, nations have their net zero targets, organizations have their net zero targets. So we aim at achieving, by combining both, and at some places we can also add a part of storage to it, and combining all three, we can have net zero establishments. And also at places we are able to completely remove DG operations. So we are committed to, whomsoever is willing and committed to net zero facilities, we are also committed and part of and partnering with them to achieve their goals. Next page, please. Yeah. So Revayu was labeled by a Swiss organization, Solar Impulse Foundation. This was in 2020 during the lockdown. This good news came to us that they selected our wind energy solutions as one of the most energy efficient solution, and it's listed on their website also. So they tagged us as one of the top 1,000 global energy efficiency solutions, and amongst renewable energy, we were at that time amongst the 10 they chose. Next page, please. Yeah, and in 2022, in December, just very recently, towards the fair end of 2022, the jury of Confederation of Indian Industries evaluated what we have been trying to do in small wind and hybrid industry, and they awarded us as one of the most innovative companies in the sector in India. So since we are talking of hybrid, this is just to give a perspective. The potential of wind globally, first of all, unlike solar, where most of the civilization is saturated, we have very consistent level of solar irradiation available. However, wind varies from low potential to moderate to high potential zones. In this heat map, you can see the blue parts. Yeah, better. These blue regions are the low potential regions, and light blue ones, the deep blue ones are least potential, light blue ones are low potential, and these green are moderate potential zones, and yellow is good, and red are extremely high potential zones for wind. So you see India falls on the left side of India, western side of India. You can see the southern and the western side, you can see there is quite a good potential. You can see the yellow ones, moderately good potential. And basically southern hemisphere, Maharashtra and MP onwards, you can see a consistent uh, uh, averagely good windy conditions we get. So starting from Rajasthan, the entire southern India and western India, uh, even the eastern side of southern India, both sides are having decently good option. So just to put another perspective, if we talk about India, uh, these two maps are one for wind potential and one is for solar irradiation potential. So if you see it closely, it is India. I described the India map in the global map as well. I've repeated. We can see the potential over here. So with regards to solar, the entire nation country is having very good to good potential of solar. Whereas in case of wind, we have to choose the location. So that's one of the reasons why solar can be adopted as a technology anywhere without any brain, without any thinking, without any feasibility studies. And for wind, we need to be more region specific, where we want to do, where the commercial viabilities would be more, where it will make a value sense for the users, and where we can have higher percentages of slightly higher percentage and proportion of wind as a mix of solar and wind. So here, this is how we generally do. That's the thumb rule we follow for regions where wind speed is 4 meter per second and above, and we come across our clients. We generally suggest them 20% of wind component to combine with 80% of solar. Why we do that? Because not only wind potential, also the cost matters. I'll come to that point, how we try to optimize the cost part, because it could have been 60-40 over here itself, 60% solar and 40% wind. But just to ensure that if the cost of wind is higher than the solar, then let's have a higher combination, a higher mix of solar in proportion to wind. So then we come to the regions where the wind speed is 5 meter per second and above. That we rate as having good potential of wind. Here it makes very good sense to have at around 25 to 30% of the mix of wind along with solar. And even though wind could be expensive than solar, wherever we have wind speeds more than 6.5 meter per second, whether it is India or globally, it makes very good sense to even have a mix of 50-50 over there, because wind would be producing much beyond what solar can produce in that mix, and will be justifying its commercial difference. So let's come to the next page. So clean energy product categories that Revayu offers. Yes, solar alone is also part of it. So, and it can be BMS integrated. Every whatever we offer, we provide remote monitoring based building management integration. And then obviously small wind. That's how we combine both to achieve a nice reliable mix of renewable energy sources. Then amongst the wind, there are multiple options. We have augmented option where we recover using our modified horizontal axis wind turbine. We recover energy from the wasted exhaust wind, which is generated by exhausts that are anyways operating. So being uniquely designed, we are able to recover energy and feed it back to the grid, to the load, and whatever we recover, it becomes a money saver and on operating cost for users, and that too with the green energy. Secondly, along with horizontal axis wind turbine options, what nowadays vertical axis wind turbine options have also picked up because of many factors. Horizontal axis, I'll come to the description later, uh, where vertical axis finds its place in comparison to horizontal axis wind turbines, uh, and then obviously third, to make it more reliable, storage always become part of a mix at places. If we want to become net zero, we need to avoid DGs wherever we can, or we want to utilize. There are, even if there is slight bit of intermittency, even after combining wind and solar both, that can be covered up to an extent with the storage part, which will be again green. So let's come to the next page. So we offer all these solutions in combination. So let me be very clear. When we provide wind solutions, we don't try to substitute solar. We always try to complement solar, and we do only solar also. There have been many instances. We equally specialize in providing only solar solutions, and there have been instances that when people have big corporates and big companies have come to us from a specific region, that we want to have a mix of wind at our place, and we have, after feasibility study at few places, we have told them that it's better we go for only solar. And big C&I client base we have. And so next, come to the next page. So I think you solar would have covered all this. So, and I would not spend too much time on solar. Just a second, come back to the previous page, please. That was an important page from hybrid perspective. So in spite of so many advantages that solar have, there are few disadvantages that goes in, which people realize, and that's why they're looking for alternate options. So no power during night, consumes expensive and scarce space, and frequent cleaning is required. So even though wind also consumes space, but you see, when we deploy solar, there is no space left which can be utilized. Whereas when in a green area we deploy a wind, or in a center verge we deploy a wind, on the remaining parts you can still have utilizable ground or surface which can be used, unlike solar, which completely covers the surface wherever we install it. So and obviously one more thing, in a country like India, the frequency of cleaning has to be very high, and a mix of wind over there where no human effort, additional human effort is required from user end. It makes a good sense to have that portion also in their mix. So, and in all these disadvantages, wind, small wind and micro wind has its advantages. That's why it complements. So if solar does not provide power at night, wind provides very good power during early mornings, dusks, evenings, and even at nights. Not all the nights, not every time, but it does provide. So yeah, So this is why solar has become the first choice, and we also uh, have a good proportion. We also suggest everyone to have a decently good, even if they want to go for wind and wind has a feasibility, solar should be part of their renewable energy mix, and these are the reasons. So uh, I think you, that's everybody knows it. So we have now we come to challenges of small. So uh, since wind has rotating parts, so this can be one hindrance, that there are some sort of sound, vibration, chances of mechanical breakdowns. Wherever there are moving parts, unlike solar, there are no moving parts. So there can be electrical failures in that, but mechanical failures, obviously it's covered, pre-covered. So that's one of the challenge that small wind has to face. How we face it, that we come to later. Non-uniform potential across geographies, as explained earlier, significantly high cost than solar. Around, as a thumb rule, it's around, if solar we consider as 50,000 per kilowatt today, we have to consider wind at 1,50,000 per kilowatt. Okay, so there's a significantly cost difference, but with the right mix, we are able to achieve that kind of the value for the consumers. Uh, Another thing, there are no subsidies when it is expensive. Any kind of subsidies to wind could be user friendly. When solar is already installed and wind is seen in isolation, a subsidy can be extremely fruitful in its deployment. Uh, no net metering policy, clear net metering policy is not there in most of the states. Wind is not mentioned in other than Maharashtra. Small wind is not mentioned uh, as a renewable energy source uh, in most of the net metering policies. So that is one of the very big disadvantage that small wind industry, micro wind industry has. Another big challenge is specific to wind industry are height hazard. People have to work at heights, and obviously it leads to complications in installing, maintenance, and also the cost of O&M. Yeah, we can come to the next point. Next slide. So how we overcome those challenges, which we just mentioned in the previous page. So jointless blades. What this does? If blades earlier, blades used to have joint. If they have joint, then it will wear off. There will be vibrations, added vibrations with the wear and tear. And added vibration means the mechanical part with increased vibration are more susceptible to damage. So the quality begins from the most critical key element, which is generating the power. So that is where we have contributed, we have worked on it. And with the advancement of digitalization, now remote monitoring and monitoring every part of it has become very important. From maintenance point of view also, it gives advantages, and also viewing whatever is happening there is much more easier, and we have adapted to it. And we have launched very silent models like 6 blade and 9 blades, where there is substantial reduction in even the swish sound that generally these turbines create. So these are very elementary disadvantages that micro wind used to have, which we have tried to work upon. Next page, please. few of the more challenges of micro wind. We have see, as I told, that if there is a moving part, there can be mechanical issues. But by incorporating electromagnetic induction-based generators, what we have achieved is there is no real friction happening inside. So there are no gear system inside. So up to a large extent, we have been able, by this technology, we are able to bring down the preventive maintenance cost and the mechanical breakdowns that can happen inside the generator. Secondly, we make sure that our generators are lightweight and of the size that can be, mounted on a tower, and such a tower that tower can be brought to the ground level, and in case of breakdowns, at least technicians, instead of going up and bringing down the turbine, or bringing a crane to the site and bringing down the turbine and then maintaining it, it can be done manually. Tower can come down, technicians can work at ground level, and then again, erect the turbine back on the tower. So that's what we are working on, and we are focused. We could have launched 10 kilowatt, 20 kilowatt, 100 kilowatt models, but we are very, very focused that we want to keep O&M costs down, and we want to provide service and ensure that whatever we have installed whatever we installed 4 years back, those turbines are working now, and we want what we are installed then should work 10 years from now as well, and maybe even 25 years. So another very, very, very important part is that the local technicians at the site or near to the site, it could be from some local technician, which, the electrician, which are always there at client site to maintain the site. At many of the sites we get them. Even if we don't get them, in that region we find local technicians who can visit the site on our request. We train them, we brief them about the system, and they become our front line in case of any requirement from the client side. If there's something happens to remote monitoring, if the power is not being generated, somebody goes to the site and make sure that if there is something very small, with a small WhatsApp call, now it can be sorted. We can tell them that try do this. Many a times we don't even need to go to the site to solve the problems. They are so smaller problems, and for those kind of problems, if people need to travel long distances, it becomes a very big hindrance. So very important aspect. Next, please. Advantages of using vertical axis wind turbine. I told I'll let you know how vertical axis wind turbine finds its place. It has much safer edgeless blades, so it's safe against human accidents as well as bird hits, which is now always has been a concern amongst environmentalists. So, and as you can see in the next image, which is in the center, we can place these very, very, very close to each other, unlike horizontal axis wind turbines, where there is a decent amount of spacing required between them, and there might be support structures required with a tall towers. Here they are self-standing with us, and close to the ground surface, and they can be placed next to each other, very close. The distance between them is less than half their own diameter, and that's sufficient for them. And so that's a big advantage that they offer. And another big advantage is that in case of horizontal axis wind turbine, why we need to take it to a more height, even at the rooftops, is because they can't operate on in turbulent air. To cut the turbulence of the building itself, we need to go 9 to 12 meter above the rooftop, even if the roof is already 60 meters above the ground level, even if it is a multi-story building. We further need to increase the height, and we can't counter the disadvantage of height because horizontal axis, we need a unidirectional wind. Whereas in this case, we can place it very near to the surface area, and where even if there is a turbulent wind, it will generate power, and it is made in such a way that it can utilize the turbulent wind. That's the reason at many places it has been used in the center of the roads where traffic passes by, and that turbulent wind created by the traffic also generates power. So that's another advantage of these vertical axis turbines, and they are silent too. We come to that. So very less vibrations and no sound. So for horizontal axis wind turbines, we need to work on their components. We need to make sure we need to add few components at the base level to ensure that vibrations don't go down. But in case of vertical axis wind turbine, it has much lesser vibrations and sound by itself, by its nature, by its principle of working. So that's not a problem at all. And secondly, since it's installed at very near to the surface level with a very small fixture foundation, so no height hazard is there for installers, for users, for maintenance providers, and that's the reason the cost of maintenance also comes down in the long run for vertical axis wind turbines. Thank you. This was a brief overview of the advantages, the challenges, how it complements. And I hope I have been able to do some justice. I have been able to provide some glimpses of the advantages, what we are trying to do, and how we will dwell more into it in the next session. So any questions?
Thank you, Siddharth, for this great presentation. As of now, we don't have any questions, but I think we will certainly have some at the end of the second session.
That would be better.
Yeah.
Even better, because automatically few of them get solved in the second part of it.
Yes. Can you see the screen for second presentation?
Yeah, I can see.
Yeah, okay, you can go ahead.
Because we know the backdrop of today's day. So.
Yes.
So here is the glimpse of few projects that we have completed this year. This is for IOCL, the first one. On the left side, we did multiple sites for them. We used 3.3 kilowatt wind turbine for them with a combination of 5 kilowatt or a 3 kilowatt solar, which they installed at their site, and we combined the wind part for them. And we are also now regular vendors to defense DRDO. We recently installed at Uttarakhand. This is a glimpse of that. We installed 5.1 kilowatt 6-blade turbine over there, and this is at the rightmost one is at Kolkata, where this is a rooftop wind turbine on a 9-meter tower on their rooftop. And there also you can see they had some solar capacity installed, and they deployed wind to complement their solar requirement. And this has been done very recently. It got completed in March itself. And this is for CESC Kolkata. They are themselves power grid suppliers. CK Birla Group. So this is the specification of 3.3 kilowatt wind horizontal axis wind turbine blade, which we it's a 3-blade model which we installed for them, and we are either doing 5.1 kilowatt or 3.3 kilowatt for IOCL at most of the locations, and combining single or multiple turbines for achieving the required kind of mix. And as you can see, the cut-in wind speed for this blade is 2.7 meter per second, and yeah, the kind of monthly generation at we have mentioned here at 4.5 meter and 5.4 meter per second is say 352 units and 568 units monthly at this monthly average wind speed, so, by a single turbine. So why we there is a special reason why we mostly mention 4 or 4.5 or 5.54 meter per second, because we personally believe that any India is in a moderate wind friendly zones. So for any turbine to generate good and to calculate its commercial viability upfront, it is a common sense to see for yourself. We would like to empower our users themselves. We provide them the data that this is the kind of generation which will happen between 4 to 6.5 meter per second of wind speed, because that's the wind that most of the time you get in a normal kind of a breezy situation. So majority of the time, since we get these kinds of wind, only those turbines are going to be viable, only those figures are going to be viable which are considered at this wind speeds. Then it has a 16 pole alternator. This is more of a technical thing. Then a carbon fiber composite material for blades which is now edgeless. Rated wind speed is 10.5 meter per second. After this, beyond 10.5 meter per second, it is anyways going to furling, and at 13 meter per second, then it starts dumping the surplus power to the dump mode. See, when there are extremely strong winds, any wind beyond say 10 meter per second or 13 meter per second for certain models is a surplus wasted wind as a resource. Okay, that's why we say that any turbine, if you want to compare between 4 meter per second, so say 7 meter or 8 meter per second. Governor speed. Governor is basically tailwind. Governor is a tailwind. Tailwind automatically adjusts and counters the disadvantage that this any turbine. As I told earlier, that horizontal axis wind turbine needs to have air striking from any one direction from where the maximum wind is coming. So what governor does is with the help of this tailwind, it automatically rotates the blades in the direction of maximum wind potential. So these figures at this stage at preliminary information level would be little we can dwell on a one-to-one basis. Next page, please. Yeah, this is for 5.1 kilowatt. like last one, the peak performance was 3300 watt. You can see this is the one we installed at DRDO Pfizer 5.1 kilowatt 6 plate. Most commonly acceptable micro wind model. This one is from as of now. So the cut-in wind speed because of more number of blades, cut-in wind speed is lower than 3 blade, whether it is 5.1 or 3.3 kilowatt. There the cut-in wind speed was 2.7 meter per second. Here you can see the cut-in wind speed is 1.5 meter per second. So hence, wherever at lower wind speed the generation starts, instead of 0 you have some generation, you will end of the year you can have a better generation. So that's how it generates more power throughout the year. So if we compare a power curve of 5.1 kilowatt and 3.3 kilowatt, then between 4.5 meter per second and 7.6 meter per second wind speeds, you can see there is a substantial difference between the generation that these two models give. This is a 5.1 kilowatt model and this is a 3.3 kilowatt model. And one more thing, like in case of solar, you have a thumb rule calculation of 4 units, 4 or 4.5 units, between 4 to 4.5 units on a sunny day for per kilowatt. In this case, as the wind speed increases, instead of the thumb rule of 4 units, we have been able to generate with 5 kilowatt model itself. We have been able to generate at 8 to 10 meter per second wind speed. We have been able to generate around 60 to 70 units from a 5 kilowatt turbine on a single day, which is at approximately double the capacity expected from a normal solar installation. So what it also tells is that when the say in a monsoon season or a season where solar performance dips and we have good winds during those times, or in the evenings when we have a good windy conditions and solar performance is dipping, with a mix of 25% wind, we can generate during those kind of winds, we can generate power equivalent to, say, similar to having 50% of solar capacity installed. So that's how beautifully it's complement this. Even a 20-25% combination can beautifully complement solar installations. When the solar installation dips from, say, around when it's a proper cloudy condition or a rainy condition, the generation is around 25% or say 30% of the overall performance it can generally give. At that point, if it can generate double that people expect from solar, so there's quite a good amount of energy loss that alone solar would have, that wind is able to cover during that time. So that's why we call it a completely complementary technology to wind. Next page, please. Let me mention, this is a very special model which has been recently launched by us. This is a 2 kilowatt model with 9 blades, a Sphero Dynamic 3D rotor, we call it. And you see, this is not a typical edgy blade. There is a third spherical dimension to it, because of which what has happened is, one, vibration and sounds are very less, negligible. Sound is not there, it works silently. Only the sound that one can hear from very close distances, just a air cutting sound. That's it. There is no swish sound at all. Soundless machine, almost no vibrations, and very less resistance to air. It can be placed at a very close distance. In spite of being horizontal axis wind turbine, it can be uh, placed close to each other. So between the two, the gap has to be equal to the diameter of the turbine. So at the rotor diameter of this, as mentioned here, is 1.8 meters. So at after a gap of 1.8 meter, we can install another turbine. So that close we can install. So the capacity in a limited space can be increased with the help of these. And it's a compared to 3-blade or a 6-blade version, since there is less sound, less vibration. It is a very good where they don't work well. They can be a very good option for a rooftop utility in comparison to 3-blade or a 6-blade model. And I come to more advantages in the next page for the same model. It's a 2.2 kilowatt rated model with a peak capacity of 3 kilowatt. Ultra low cut-in wind speed of 1 meter per second. So at as low as 1 meter per second, it starts rotating and generating some amount of power. And the biggest advantage is one more biggest advantage is that it has very low lateral thrust, which means lateral thrust means when the wind strikes at high speeds, the weight increases in Newton tons. So you can see for 5 kilowatt wind turbine, it is 4,500 Newton ton. Even for 3 kilowatt wind turbine with 3 blades, it is 4,500 Newton ton only, the lateral thrust. But with this 9-blade model, it is 220 Newton tons, which is say 20 times lesser, which is a significant improvement. And for its energy generation size, if we compare to the conventional blade or a 6-blade model that we are deploying at presently, its size for its capacity is 2.5 times lesser. What that means is that that's because of the additional dimension, 3D dimension that we have added, because of which the size has shrunk and we have the advantage of space. So another biggest advantage is no back pressure. Because of this biggest advantage of no back pressure, we have been able to install it in front of exhaust and achieve energy generation out of it, because rest of the conventional blade turbines throws the air back towards the direction of from where the wind strikes from the front of the blade. So what happens when the exhaust is operating? If it throws the air towards the blade, and when our turbine moves, it throws the air back towards the exhaust, then it won't work in that industry. It is a failed product. But because there is no back pressure, it dissipates the air instantaneously backwards. So we are able to deploy it for exhaust energy recovery, which is another application which has been patented by Revayu. And drag and thrust are correlated. So if thrust is low, drag is also very low. Efficiency of energy, coefficient of energy conversion is also very high. It's around 0.8, and near silent. Peak RPM, again, see the difference in peak RPM. The rest of the conventional blade, the peak RPM goes from ranges from 360 to 400 at maximum wind speeds, whereas in this case the peak RPM goes to 220 only. Since it self controls its peak RPM, so all the components are very less susceptible to self damage during extreme windy conditions in comparison to the ones where the RPM goes to the higher rate of 400 and above. And because of its lesser size, it can be installed at relatively lesser height. And next page, please. So this we have installed. Let me just tell you, we have installed this turbine at few of the most prestigious organizations. We have installed it with ITC. We have installed it with Ultratech, and we are discussing with many more organizations, with top-notch organizations like few of them pharmaceutical industries as well, which have big, huge capacity exhaust, textile industries, where we are in talks for their energy recovery requirements. Now we come to vertical axis wind turbine. So this is a 4,000 watt or a 400 watt, sorry, 0.4 kilowatt or 400 watt wind turbine. This is a small 1230 mm height wind turbine from the base, and the diameter is around 600 mm. And this starts rotating at the cut-in wind speed. It starts rotating at 1.8 meter per second. The rated wind speed is 16 meter per second. So what happens in case of vertical axis wind turbine is that it starts rotating at a very low wind speeds. It is made of aluminium alloy. It's a lightweight body, and because of which, and we want it to start rotating sooner, but it picks up peak generation at relatively high RPM in comparison to horizontal axis wind turbine. Therefore, vertical axis wind turbine makes a very good sense at a place where heavy traffic is plying, or at a place where wind speeds are above 5 meter per second, because it generates its generation curve has a sudden steep increase beyond 5 meter per second. So we should install these at places where we have regularly good wind speeds above 5 meter per second, or where we have a tunneling effect. Many a times, at commercial premises, we find certain places where there is even a turbulent wind created, and there is some kind of tunneling effect created, where if we move, we always feel that even though there is not much breeze around, but when we pass that region, there is always some kind of breeze flowing. So at such locations, this can be a beautiful application, and turbulent wind makes no difference to this. And silently, but it keeps on generating some amount of power. And when multiple units are installed together, it actually decently adds to the overall capacity. And one more thing, since it can be installed in a leftover space. See, even if you are installing solar, at left and right hand side of the same terrace, you can install 20 of them on the circumference of the roof or wherever you want. And since they can be placed very close to each other, so you can install a very decently good capacity without losing much space when you install these. This is the biggest advantage in urban setting that this vertical axis wind turbine provides. We have launched 400 watts first, but we have plans to launch more models sooner, up to 1 kilowatt. Next page, please. So this is the kind of monthly generation you can expect at these average wind speeds. Again, I have stopped it at 8 because, as I told, that naturally, if you see at natural wind, this is the kind of, the bracket where most of the time you will find the wind flowing. So 4 meter to 8 meter. Uh, this is the power generation that we can achieve from one unit, and this is 400 watts only. This pages got swept up. I have explained this page verbally, the advantages of 3D rotor turbine, which I explained previously to the vertical axis wind turbine. These facts are mentioned here. So low RPM results in longer life of all mechanical components. Maintenance cost is also less in both, in this 9-blade turbine as well as this vertical axis wind turbine. Very nice model for urban settings. Now, instead of giving a brief of what models we offer and what specifications they have, let's have, as I said, let's have a informed, empowered decision making. So I have very simply, without any jargons, tried to put forward the decision making criteria, which is driven by common sense, more of a common sense. There are not much technicalities involved. There are basic thumb rules, basis of which not me, any user can themselves decide what they want for themselves. So average annual wind speed at the location is the first criteria before deciding a wind mix, as I mentioned earlier. So we categorize it as follows. At around 4 meter per second, less than 4 meter per second, we call it annual average wind speed. We call it low wind potential zone. Between 4.5 meters per second to say 5.5 meter per second, it's a averagely good wind potential zone. We welcome such zones. And between 5.5 meter per second to 6.5 meter per second, it's a good wind potential zone. And if this kind of wind we have, we get encouraged and we try to increase the energy mix of wind part. We increase the wind part in such kind of situation. And as I mentioned in the first part of the presentation, if the wind speeds are above 6.5 meter per second or say 7 meter per second, it's considered as very good wind potential zone, and we can increase the capacity of wind and solar mix to even 50-50 at such wind speeds, because generation is very high and it is able to justify the cost difference at those annual wind speeds. Cost of micro wind energy versus cost of solar energy is another big criteria for selection of any wind turbine. Cost, see, if solar got adopted by the industry and sustainability has become goals of the company, it's not only the sustainability. The end of the day, they are looking for bringing down the operating costs, and any sustainable solution having the ROI more than 5 years, return on investment more than 5 years is not acceptable in industries and corporates, and even initiators. And anything around 3 to 3.5 years get adopted very easily, but beyond 5 years it gets very difficult. So cost, yes, absolutely is one of the biggest criteria. So total renewable energy mix planned, including both wind and solar, becomes a way to choose. In low wind potential zone, we suggest you can have say around, if you are keen, you can have say 10% of the total capacity as wind, because at least when when solar potential is less, that's the time when the wind potential increases, and it provides some additional power and consistent power. Some kind of compatibility is there. So those who are keen, they can add say about 10% of wind at low wind potential zones. In averagely good wind potential zones, we, as a thumb rule, these are thumb rule suggestions that we provide to client, that 15% of your energy mix could be uh, uh, wind amongst the combination of both. And at good wind potential zone, 5.5 to 6.5 meter per second, 20% can be. And at very good potential zone, we can increase to say 30 or even say 50% also. Another very big constraint can be space. So in urban setting and in any building, why solar got adopted so easily is because where there are sloping sheds, solar got installed on sheds also, on slants and slopes also, and now people are integrating vertically also. But with wind, we still require either ground or roof, or some kind of uh, horizontal surface where we can plane surface where we can mount. And even at ground level also, wherever there is uneven land, we need to first do the ground leveling done over there. And so yes, kind of space is also the criteria before choosing wind. Factors influencing choice of off-grid and on-grid. Why I have bracketed these 3 points is because all 3 points are interconnected. Compatibility with mostly available grid tie inverters is one of the criteria which affects whether people choose off-grid or on-grid. MPPT algorithm mismatch is another thing that happens. This I'll tell you what happens. See, most of the industry is flooded with inverters available for solar. Separately for wind, very rarely we find inverter. It is very difficult to find because it is an evolving industry. People need to arrange it, get it customized, and when we pick it, if we try to fit the 3 kilowatt or a 5 kilowatt normal grid tie inverter, these MPPT are designed for PV strings as per the power curve of solar panels strings. So unless the MPPTs are designed specifically for micro wind, the optimized extraction of power will become a misfit, and there can be energy losses, which during the grid connectivity, because of which the expected generation can dip down during actual practical installations. And I'll come to it, what we are doing for that. So, and most of these inverters have relatively high minimum cut-in voltages. So, since they are designed for solar, they achieve higher voltage points. So, most of the time we find even for a small turbine like 3 kilowatt or a 5 kilowatt, the starting voltage would be 60 volts. Whereas what happens that below that voltage, the inverter will not start feeding the power to the grid. It will be on a standby mode. It will not work at all. So when such thing happens, any power generated below that voltage, because even when blade rotates at lesser wind speeds, at lower voltages also some power is generated which should be fed to the grid. But when inverters are designed for higher voltages, any power generated below that voltage gets completely dumped, which is a big loss which can happen with the grid tie inverter if uh, not chosen properly. Uh, this is the biggest hindrance which we face at most of the place. Even if people are ready to install a grid tie inverter, so grid tied turbine, at most of the regions there is no clear net metering policy. It has happened with many of our clients that they got it grid connected. They had to, they were forced to change it to off-grid mode at few locations out of Maharashtra where there is no clear net metering policy for solar. So what we do is we choose low voltage uh, grid tie inverters, and we feed directly to the load. We don't export, we feed directly to the load, and uh, and we install at places where the power requirement is very high at any point of time. Whatever power we generate, there are no chances of losses, there are no chances that it need to be exported or something like that. So, and we also choose very relatively very low voltage grid tie inverters. Also, now we are ourselves designing proprietary MPPT, which would be based on the power curve algorithm of micro-wind turbines, where we can, maximum. Another thing, unlike solar, it generates DC power. Wind generator generates AC power. First, since in these inverters are DC inverter and batteries are also DC, in both the cases, we first convert the generated AC power to DC power. Whenever there is a conversion, there will be a loss. Now, to feed this to the load, now DC power through that inverter is again converted into AC power. Again, DC to AC, there will be some loss. So now we are also working on a concept after this MPPT. First, in the first phase, we are doing MPPT, and very soon after, we are trying that there should, in a grid tie scenario, if we can control and feed AC power to the AC load without converting it to the DC. So instead of a regular solar inverter which feeds DC to AC, we can have a separate independent inverters for wind which uh, you know uh, controls AC power and stabilized AC power can then be fed to the uh, uh, load. So this is a typical grid tie SLD. This is a first is the wind turbine uh, where three-phase line is there. Then we install a wind charge controller, and as I said, it generates DC power. DC has it AC power, and feed is enters the wind charge controller. From this wind charge controller, it gets converted to DC, controlled DC. The surplus power goes to the dump, and this goes into this is grid tie inverter, or we have a battery over here. We have to choose as per the system design whether it will be an inverter or a battery. For both, there is a slight difference in the settings that we do before uh, when we discuss with the client, we finalize, and accordingly controllers are configured in the factory settings. And then there is a, if because of any reason people want to switch off, there has to be an MCCB in between before the final termination, from where we can disconnect the wind when we require, even for maintenance purpose also sometimes we need to disconnect. So there is MCCB to disconnect the system from the normal supply mode. And there are things done at various level for the safety, because because even the entire structure is metallic and it is suspended to the height, it becomes even more critical to properly earth and ground the lightning and surges. Next page, please. So till now, I was in the previous page, we saw that how a single turbine would feed to the local grid. And now, in case we have multiples, how we generally do is, you can see for every single wind turbine, there is a with their wind charge controller. All of them have their independent wind charge controller. There is independent dump load for each one of them for safety reasons. Why we need to do so much? Why we can't make a single string is because, unlike solar, wind is very dynamic. The voltages within seconds can vary, very hugely, and the peaks and lows are quite extreme. So we suggest that dedicated controllers and inverters are installed with each turbine, and then they can be terminated at a common bus. This is a small mini wind farm of say six turbine. We have completed such installation in Chennai recently. Next page, please. This is basically for different models at what voltage points we have dump load activation or diversion of load, or what is their rated output. So with the help of this, if you keep it with this, keep it with yourself for your records also, it gives a very good idea and it helps you in informed decision making. Especially this one is more suited to off-grid kind of situations where there is a small battery bank in between of 48 volt battery bank. Why I'm saying 48 volt? Because mostly we promote wind turbines of higher capacity, slightly higher capacity, 3 kilowatt or a 5 kilowatt. We say if you want to go for a lower capacity, then it is better you go for vertical axis wind turbine of 400 watts, which will have much lesser overheads in comparison to horizontal, and it will justify its cost in terms of overheads. So since the overheads and overall capital investment difference is less between the two models, the higher the capacity of the single model is, more justified the costs. So this is the point. Diversion load is the point when there is a cutoff, and the surplus power generated is wasted through the dump loads through heat dissipation. This is for the safety purpose, so that there are no surges beyond a controllable level in entire settings that we create. So that's why beyond 30 meter or 15 meter per second, whatever extra winds are there, they basically goes to dump only. So this is a component wise, just to give an idea of components. See, this is insert adapter where turbine is inserted. Yaw assembly is basically attached to the governor through which tail vane is attached, and the turbine moves in the maximum wind direction. So this is the rotor drum inside which there are magnets. It has a 16 pole magnet alternator inside, and these are the blade mounts where this is a 3-blade model. So there is a place for 3 blades to be mounted over here. 1, 2, and third one is on the other side, which is not visible from here. So this is the stator core. Stator means the stationary part, and rotor core is the rotatory part. So this is this stays stationary, stator core, and there is a slight gap between rotor and stator, and there is no, as I told in the while I was mentioning in the previous part of the presentation, there is no physical friction. It's based on electromagnetic induction. So there is, when rotor stator moves, there is because of the magnetic field and the copper windings, the power is generated through the generator, and there is no damage due to friction, actual friction. So this is return spring. Here is the return spring. It has a very important role. When a turbine moves, or because of tail vane, when because the turbine can move in 360 degree to the maximum wind direction. So what this can do is, this can cable can get tangled because of that. So this return spring ensures that that cable is not tangled in case it moves multiple times in multiple directions, maximum wind directions. Next page, please. So now we come to battery capacity estimations. Very frankly, battery capacity estimation remains same whether it is designed for wind or solar. However, as I told, few challenges that existed in the industry, and still to an extent they exist. So wherever there is wind, chances of battery adoption increases. अगर ऑफ ग्रिड पे कर रहे हैं, डायरेक्ट लोड पे भी if we are feeding directly to the load through the batteries, and even if there is a reliable grid and you don't require batteries, sometimes people have been installing a small battery bank as a medium, so that at low voltages also they are able to store that energy and utilize it when the batteries are relatively charged. We can have microcontrollers where when the battery is 70 to 80% charged, it feeds power to the grid through batteries, and when again it gets to 30% level, again it cut off the battery charging mode, and it can feed through the battery at all times. So most important factor which one should consider other than cost. Commercial people consider cost, but for technical people who are designing, depth of discharge of battery is the first thing that they should notice for designing, because you will come across this figure which is 80% or 70% or 85% or 50% is the depth of discharge of that battery bank. That's the prescribed. What is DOD? DOD of any battery is a percentage of rated capacity prescribed to be used. That means for its normal long life, which is prescribed by them, and complete its just number of cycles for which that battery is made, you should not allow the discharge beyond 80%. And this is for lead acid. For VRLA, it could be mostly, it is in this range as a thumb rule. Some, the better versions could have different percentages, but this is for thumb rule that VRLA and lithium ion, the DOD is around 50%. This is where people get confused. From ampere hours, people are able to calculate that what is the capacity of any storage battery storage device in kilowatt hour by simply multiplying ampere hour with the voltage 48 volt. We are able to arrive at 9600 watts, which is 9.6 kilowatt. That's the capacity of the battery. But with this DOD, what happens? You now multiply it with 0.8 or 80%. So this is the capacity. This is the storage capacity of the battery that you can actually utilize. Beyond this, if you go, then you will compromise with the life of the battery and even the performance. So for VRLA, it is 50%. So when you multiply the same capacity battery, say 200 Ah battery with DOD of 50%, then you can actually consume only 4.8 kilowatt. So with lithium ion and VRLA, that's why it is said that if you want to feed to a 3 kilowatt load, then make sure that when you choose a battery, you at least choose a 6 kilowatt, equivalent to 6 kilowatt. Okay. Almost double. So, factors for battery capacity estimation. Reliable grid will require lesser backup, and unreliable will require more backup. That's the second criteria for choosing any battery. Remote locations, actual backup is required. In rural locations, actual backup is required. And even in semi-urban, urban settings where reliable grid is not there, from Delhi, when we have an office in Noida, from Delhi to Noida, there is a big difference in power cuts. So still, even at relatively urban settings also, people need actual backup. And when people need actual backup, then as per load, very carefully we should design. So this is a thumb rule calculation which people can follow to design how much capacity they should go for. If people have all the backups already in place, and and if you are installing at a place where there is a reliable grid, if you are deploying storage, you can bring down the capacity of storage, and this is how you can calculate, because we have already calculated what you can utilize as per DOD. Now, if this is the capacity, this is the load with which you are connecting, divided by the quantum of load with which you are connecting with 3000. If you are connecting with 3000 watt, divided by 3. If you are connecting to 3 kilowatt load, divided by 4, and this is the hours for which it will deliver, the batteries will deliver to the load. After that, it will reach maximum the DOD point. So mostly hybrid projects are say ranging between 10 kilowatt to 200 kilowatt. So we are currently operating Apex model. We hello. Cost of battery option is another big factor. So for lead acid, these are the thumb rule idea that I have given for calculation. So anybody based on these calculations can themselves, figure out how much they want to install. So this gives idea of financials, cost of battery, backup required. I have given a thumb rule idea how to calculate for how much hour it will be able to deliver. That's next page, please. So if you have requirement, anybody has requirement for additional source or only for solar, we have been providing only solar also. We have been providing only wind also. We have been providing solar wind also, and we have been providing solar wind storage also. And most of the places where we have installed till now, solar, wind, and storage have gone together. That's what the time has come when we can achieve with both the sources the net zero. We can create net zero facilities or near net zero facilities. So one hello. Thanks a lot. Thanks a lot.
Thank you, Siddharth, for such a detailed and informative talk. I'm sure everybody now has some information regarding the wind solar hybrid system. There is one question by Moirang Thimset. They have asked, is it possible to connect wind power to existing solar system?
Existing solar system, I would call it, is it possible to install it to the grid? Yes, we can connect it to the grid, but if in case you are not in Maharashtra and you have already deployed the full capacity as per net metering policy norms, or if you are out of Maharashtra, the net metering is not possible, so you can export the surplus power, but you can always feed it to the grid alongside solar. Mostly instead of combining with the same inverter, we don't combine it with the same inverter. Mostly we provide independent dedicated inverter. Even for a I showed you a SLD of a wind farm where for each turbine we had a dedicated controller and a dedicated inverter feeding to the bus. So that's gives you a relatively good idea that it will be, in spite of being a hybrid, it would be more of a parallel system instead of joining it to a same inverter. If we say that we can provide connect to the solar, that does not mean that we can connect to the same inverter. Please don't take it that way as of now. But yes, we are in the process that we make our own inverters, from which we in hybrid inverter up till now means those kind of inverter which can feed to both grid as well as batteries, which can be grid tied as well as can feed to the batteries. But the new controllers that we have in making, probably we can have a single inverter for feeding solar as well as wind. It will be a bit on the expensive side because it will have to have inculcate both parts, but it is still distance away. So as of now, parallel, not joined to the same inverter. That's the answer.
Okay, thank you, Siddharth. This brings us to the end of the talk.
Okay, that's great.
I would like
Thank
to
you.
thank everyone. Yes, thank you, Siddharth. And I would also like to thank everyone who attended and participated in this talk. I would also like to take this opportunity to remind everyone that we will have our second last RE Tech Talk on 21st of April, Friday at the same time. We will discuss another hybrid technology, which is solar and geothermal. We assure you that it is going to be a very interesting session, and we hope to see you all next time. Thank you and have a great day.
Thank you.